Hello, everybody. My name is Sasha Nosov, and here I have my partner in crime, Ayo Olubeko. And today, we're going to talk about distributed database applications, how to design them, how to use the existing technology we have in Azure SQL Database. First of all, I want to thank you, everybody who is streaming this session or maybe later on downloading it. I hope you will find that session useful for your future design efforts. First of all, what we're going to try to do here is we want to make sure you can learn about the scenarios for globally distributed applications. We also want to make sure you understand how the existing technology, gr application, and failover groups help implement those applications. And as a takeaway, I want you to realize that we already have the technology today that made these applications easy for you to design. And a couple of calls to action. We specifically designed an open source application called WinTips that demonstrates the power of SAS application and integration with the gr application and failover groups. And the other call of action is to download this application, use it as a template, and learn how to design SAS application and also how to integrate these applications with the geodistribution and gr application patterns. I want to start with this picture. As you can see, Azure platform today has 38 different regions in the world. It's more than AWS and Google combined. It's a tremendously distributed, available footprint of capacity. So why am I bringing this picture up first? It's very important. It means you have 38 data centers at your disposal, and you don't have to pay anything up front. Think about how many corporations can actually afford that sort of footprint globally. Very few, which means most of you probably can't. But in addition to that, that geo-distribution of Azure platform enables a lot of very powerful scenarios for you. Now, number one, it can be used to guarantee data protection, disaster recovery in case there is an outage in a specific region. And we've just seen pictures on TV about the powerful hurricanes in different areas. Imagine what could happen if such hurricane hits a data center. You can leverage this distribution to achieve compliance and business continuity for the applications. Very often, it's about recovery, of course, but you also have to prove to the auditors that your application is compliant. Now, globally distributed applications could be designed in such a way that you optimize the location to the customers, the end users that actually use them. Make sure that they don't have to go across the ocean to connect to an endpoint that they need. And finally, you can also think about designing your application by partitioning your data set by regions. You can optimize it in such a way that most of the European users will always hit the European data in Europe, whereas most of the US users will hit it in the US, etc. So this is what we're going to talk about today and demonstrate, and we have a demo to prove it to you. Now let's start with the first scenario. It's very basic. Call it basic data protection. Because we have these different regions in different parts of the world, we use it to make sure that the data itself is protected. Every database you create today has a backup. We automatically take that backup and we put it into Azure Storage that is geo-replicated itself. So Azure Storage has the notion of paired regions. So for example, if you have a database on the West Coast, we put it into storage. Every backup that we take will be put into the storage, and that storage gets geo-replicated to the East Coast. And I'm showing on this map all the sort of pairing, at least in the US. What's interesting that if there is a failure of some sort, or there's some sort of regional disaster, you can always restore your data. You can rely on the fact that your data is protected because of this variety of regional presence of Azure platform. And also important that when you restore, you don't have to restore in the region in which your data, which protects your data. You can decide essentially to say, okay, I know that my backup is in the East Coast, but I want to restore it in the US Central, for example, or India for that matter, or Australia, or any region you wish. You can do that. And the reason for that is because we put our backups into our AGRS storage, which means it's a geo-distributed storage that has also the read-only access. So we can always access the backup that is placed or geo-replicated and restore from that endpoint anywhere in the world. And that is done very easily. You can do it in the portal or using any API, PowerShell, or ARM. That is something that is done for you automatically. It's just an example of how we leverage the global footprint of Azure. The next one is a scenario where we use different regions for business continuity. Business continuity typically refers to of recovery from the disaster with very low downtime. Essentially, how to make sure that my application runs all the time in spite of potential outages, potential disaster, potential destructions of different regions. So the assumption in this scenario is that all operations in your application require read and write access. So basically, it's a case of sort of a traditional OLTP pattern where your application reads and writes transactions and reads data after transactions are written, etc. And you want to make sure that this operation is protected. You want to make sure that you don't take long downtime, even in the case of a massive unplanned event. So in order to achieve that, typically you would want to have your database geo-replicated to a different region, as well as your application itself, let's say a web tier that controls access to the data, also replicated and deployed into two different regions. That is to ensure that if we fail over the database, your application connects to the database through the local area network, not across a long distance. So, and the business criteria here, business assumption is the downtime for the application is a higher business risk than data loss. So for example, you can say, I can tolerate maybe a few seconds of losing lost transactions before everything went down, but I cannot possibly take a long downtime because it impacts my bottom line. That's the scenario for this case. So the way it works is, as I said, you deploy databases to two different regions using geo-replication and failover groups. And we'll show how it sort of in reality works. And you put a web app or any sort of application tier object on top of it. When you create the failover group is essentially a policy that you configure that says, this set of databases must fail over together. And when you access it, you have this special endpoint that you connect to. And when failover happens, that endpoint automatically gets redirected by DNS to a new region, so that the application doesn't have to do anything special to be able to continue to work after the failover. So in order to implement that scenario, you also have to configure a Azure Traffic Manager profile, and it would use a priority routing method, which means it basically routes to the first endpoint in the priority list, but if that endpoint is offline or degraded, then it switches to the next one in the priority list. In this particular case, you have two endpoints, and while they're both online, only the first one is being used regularly because essentially the region B here is your backup region. Now, in the failover group, you have the ability to configure the grace period, which is basically a period of time that you believe you can tolerate the downtime. For example, you can say my SLA requires that in the case of a disaster, I have to be able to restore everything within an hour, which is kind of a traditional parameter that many applications have. This is, again, we're talking about the major disaster of region-wide or data center-wide type. So if you configure that to a minimal amount, essentially what happens is if we detect, as a service, if we detect that there is a high-impact, unplanned event in region A, we know that you already configured a policy that says, please fail me over automatically. And in that case, we take your databases, we initiate the failover, the database moves, the active database, the primary database moves to region B. And because you already have a web app 2 deployed in that region, that application gets essentially activated immediately because all the traffic by Traffic Manager will be directed to that secondary region. And that's what this picture really shows. It shows that once an event occurs, and once we trigger the failover, that read-write endpoint that the application uses to connect to the database is redirected to region B, and the whole application stack is running as normal. Except now, it is all in a different region. And of course, when the region A finally gets recovered by Microsoft, you have an option of failing it back, or we will fail it back for you, depending on how you configure your policy. If you want us to fail back immediately after the recovery, we can do it. Or you can wait for a while and see what happens, and then initiate that failback, we call it, to the original region when it is most convenient for you. So the benefits of this approach is you get the lowest possible RTO for the recovery. And predictable performance because, like I said, your application and the database is co-located in the same region. So regardless of the failover, you don't have all of a sudden the different latency parameters with respect to the application and the database. They're all located in the same data center with the same local area network. And depending, of course, where your browser is, for example, in this case, the latency of this browser will be determined by where you are with respect to the new region. In typically, all the geography we support have at least 2 data centers. That's precisely done for this scenario so that you can deploy a redundant stamp of your application. And in general, the latency will be comparable. So the trade-off in this case is that this secondary region, the deployment, the application stamp that you deployed there is essentially a standby. You have to pay for it, but you're not really using it other than to protect. So this is effectively makes your deployment more expensive. And most cases, people use that pattern for applications that are absolutely business critical, that require this for compliance, and have a requirement for lowest RTO possible. So this is where I'd like to start showing some of the parts of the demo, and I'll hand it to Ayo to start demonstrating this wingtip application that, as I said, is available for all of you. You can download it as an example, as a template for you.
Excellent. Thanks, Sasha. So what I have here on my screen are two resource groups that I've already pre-created for these demo purposes. But before I drill into there, I kind of want to show you the app and talk about what the app does and what we're going to be doing with it. So Sasha mentioned that the app is open source. It's over here in GitHub. And it's a multi-tenant SaaS application. It's a sample we created to show you how to build apps and, in this case, configure them for disaster recovery so you can practice what we're talking about today. So the app is configured with a catalog database that has a location of every single tenant inside the SaaS application. In this case, a tenant refers to a venue. This is a event ticketing application that we will go into during this demo. So let's get right on it. I'll open my resource group over here. And what I'm going to do now is show you what the app looks like, what we're going to be working with. So this is a traffic manager instance that points to an endpoint that allows us to see the app. So it's called Wingtips. That's a ticketing platform. And these are sample venues that we've pre-created into the app to allow you to play with it and see what you can do with it. So let's go to Contoso Concert Hall. And what you see here are the events that are available, concerts and musical journeys. You can purchase tickets, sign in, register, and generally the things that you expect you'll be able to do in order to purchase a ticket. But for the purposes of this demo, I want to illustrate the pattern that Sasha was talking about for disaster recovery. So what I've done ahead of time is pre-create the SaaS application into multiple regions. And I'll let this load here. And I've pre-created the application into the East US 2 region and the West Central US region. So let's take a look at the application right now, shall we? So what I want to show here is what region that we're currently operating in. And one of the things we added to the sample here is option that shows you what server and database the page is currently serving from. And this allows us to track what region we're currently deployed in as we're running this demo. So let me do a quick DNS resolution here. What this allows me to do is to show you in the backend what region the server is connected to. So run a resolve DNS name here on tenant pool 90103 database.windows.net. And what you can see here is this is running in the West Central US region. This is currently where the primary is. And what I'm going to simulate now is a disaster occurring to showcase what we've been talking about. So I'm going to navigate to the app and misconfigure it to simulate a disaster.
And that is only because we don't have a real disaster. We cannot take the data center down just for the demo.
Exactly. So let me do that right now.
So you're just basically corrupting the config.
Yes, this is correct. Now, because of a property in DNS called TTL, it might take some time for us to see the change that has occurred. But let us try one thing. So this is the same sample application we saw before. This is what I just tweaked. So let's try refreshing this page and seeing if there's a misconfiguration.
Do you think the traffic manager already detected the outage?
Yes, that's a good point. Let me navigate to the traffic manager.
Yes.
So let me pause here and explain what just happened. In your Azure web app, the traffic manager instance is currently pulling the app consistently to check if it's active and running. And because what I did earlier was switch the configuration to misconfigure the app, what we can see here is the health check has failed. And let us verify this is the case. In the console hall. Seems DNS hasn't completely refreshed yet. It's no problem.
Try from the link.
Yes, that's a good point. No problem.
One thing to remember that this is all DNS based, so DNS has a certain time to live configuration. So
Yes.
every time we make a change in the DNS, it
does take some
sometimes
time
yeah,
to
it
ripple.
does take some time. So eventually this application will fail.
Let's give it a couple more seconds while I check the configuration to make sure this is the case. Haha. All right, let's take a look again.
Did you change the wrong one?
Yes, it looks like it. I might have changed the configuration in the recovery region.
I see.
So let me undo that change.
That's right.
Live demos, everybody. Yes. So let me explain what just happened here. We have two instances of the app running, one in the primary region, which in this case is West Central US, and another one in the East US. The configuration I changed was for the secondary, and so I've reverted that back. And what we should see here is the app taking longer to pull. Going back to the traffic manager instance should show us that this endpoint is degraded now, like we saw earlier. And so what we see here is traffic manager is currently recognizing both of the instances as degraded. So I've reverted the change to the recovery region. We'll give it a second or so for the DNS configuration to catch up.
Let's try it.
So what we're seeing here is the recovery instances of the app is back online. But the app hasn't loaded yet. It's still, oh look, it's crashed. So what we want to do in this instance is do a failover to the recovery region. The app is not working. A disaster has occurred. So let me show you how you do that. Now what I'll do is I'll walk over to the failover group I've configured as part of this demo. It's available from the SQL Server that stores all the tenant databases. So if I walk on over to it, I can issue a forced failover to tell it to migrate to failover all the databases to the recovery region. And this should allow the app to just pick back up right where it left off and continue working.
Okay, so because the failover and also the DNS propagation will take some time, in order for us to make progress on the session, I'd like to continue, and then we'll get back to the result of the failover and to see what happens with the app in the new backup region. So let me basically, first of all, summarize the key benefits of the failover group. This whole design is really based on the integration of the SaaS app with the failover groups provided as a feature of SQL database, Azure SQL database. I mentioned that it manages a group of databases. Essentially, it allows you to say, this group is required for the application to run. I want it to fail over as a unit. When I fail over, nothing changes for the app. App can continue to run using the same exact connection string as before. You don't have to manage any changes. All you need to do is essentially see when the application sort of auto-recovers. The policy allows you to configure the grace period so you can decide if you want to wait. For example, if it's a kind of intermittent failure and it'll get self-healed or maybe recovered by Microsoft quickly because of the extent of the outage is not great. So you can do that. Or you can actually say, OK, I'm going to let it work through, because they take a little bit of downtime. But at least if Microsoft recovers it, I don't have to do anything. It doesn't lose any data. So you can have multiple failover groups for the same server. It's a policy configured on the server. But you can decide these 5 databases belong to one application. These other databases belong to the other application. Or you can even decide that in the same application, you want to do multiple failover groups because there are different classes of databases inside of the application. Any database can be part of the group. And if you're already using GeoReplication, because GeoReplication has been available for a number of years, you can basically just use the same configuration. You just enroll these databases into the failover group. And now they become sort of managed by us instead of you having to deal with the failover and monitoring and the rest of it. So I'm gonna move to another application. Another pattern, because it's really just an extension of what we already talked about. It's kind of the same thing, except your application supports sort of distinct read-only mode. For example, SharePoint is a good one. If SharePoint somehow has a problem, sometimes you may see that documents are readable but not writable. You cannot change anything, but you can always read. Same happens with some of the financial institutions. You may have noticed that during some of the maintenance windows, you can read or get your transactions from your account, but you cannot transfer money, etc. So that is an example of applications where there is a distinct separation logically between 2 modes. Again, same logic of the web tier. It needs to be co-located for performance reason. But most important difference between the previous case and here is the fact that you cannot tolerate data loss, or at least you know that data loss is a high business risk. In this case, you configure your application in such a way that deploy the same way, but now you use a different endpoint. We have a notion of read-write endpoint and read-only endpoint. And your read-only mode, because it's logically separated, always hit the read-only endpoint. So what happens is when you create a failover groups, you usually maximize the grace period. For example, you can say, OK, if it's a real disaster, I can wait for 8 hours. And in case Microsoft recovers the region, everything is back to normal, my data is intact, I'd rather have my customer operate in read-only sort of degraded mode, but I cannot lose their data. And even if it's a second of data, I can't, because it's highly sensitive, highly critical, etc. So in this case, the failover really is something that is controlled by the traffic manager. Traffic manager basically redirect the traffic to a new region, but you never trigger actual failover, or we don't trigger actual failover until the grace period expires. Only then, as a last resort, because clearly this is a major thing, we would fail over. In this case, you would wait, effectively give Microsoft time to recover, but your application will be still online, but in the degraded mode. That is the case for, like I said, applications where data loss is a high business risk. So benefits, obviously, optimized for data preservation. And in read-only, it essentially fails over instantly. As soon as Traffic Manager detects an outage, it fails over the traffic to a new region, but it'll be in read-only mode. The trade-offs for read-write mode, for full sort of capability of the app, it's a longer downtime. And again, just like in the previous case, the deployment in the secondary region is only used when an unplanned event happens. Now, before I go further, let me go back and check what happens with the demo.
Yes. So we're back here at the failover group screen we left off. And let us go take a look at the databases that exist in there. So what you see now is our primaries for our databases are now in East US 2. And the secondary is now in West Central US. Let's go over to Traffic Manager to see what the endpoint status is. That's over here. We can see the app in the home region, which in this case is West Central US, is still degraded. But the app in the recovery region is online. So let's take a look at how that's going. And what you can see right now is the failover is completed. Your venues, your databases are in the recovery region. But how can you tell? How do you know this is the case? Let's verify this, shall we? So if I navigate to a tenant, in this case, Contoso Concert Hall, like before, what you can see is the server it's connected to is the failover group, like before. But this time we want to see where this page is getting served from. So if I run the same command, just like before, let me clear this out of my screen and run it, just tenant pool. You should see that instead of West Central US, this is now in East US 2, telling us that the entire app is filled over and we're back online and good to go.
Thank you, Ayo. So this is a great basically illustration of the fact that your browser has not changed. You don't have to do anything other than retry. And after a certain amount of time, where DNS basically propagates, typical configuration of TTL is 5 minutes. In 5 minutes, your application back up and running. So there is a little bit of a disruption for the end user, but nothing that anybody needs to do, neither the end user itself or the application owners. They don't have to change anything other than basically wait for that sort of period of time when DNS propagates and failover finishes. And after that, the application is back up in business. So let's move on and try to expand on this same ability of effectively relocating the primary and look into more advanced pattern, which we call follow the sun. This is the case where you can use that to create truly distributed applications designed for end users located in different geographies. So the idea behind this is that you basically optimized for most performant access to the application for the users that are mostly active at any given time. And of course, typically what happens during the daytime, the activity of the end user is the highest, whereas during the night, it's probably lowest. So we have an opportunity to kind of use that to make sure that the application is relocated to a different geography at the appropriate time. So one of the things that important for that pattern is typically it means the read access is super critical because most of the activity is typically read-only. You browse, you for example, commerce shopping or downloading pictures or some other sort of information, exploring information from different sort of sources, etc. So this is typically very, very highly read-bound. And we want to make sure that all users everywhere in the world are optimized for that experience. So here's what we're going to do. Basically, we do this by distributing the database to multiple regions. In this case, let's say US East, North Europe, and Southeast Asia. So when it is a daytime in the US, essentially the application is available for read-only and read-write access in the same geography. The profile in Traffic Manager is configured what's called geographic routing method, which means basically it detects that the end user is located in the same geography, and it routes to the location in the closest data center relative to where the end user is. So when the daytime in US, all operations basically go through the Web App 1 in the US, and Web App 1 connects through read-write endpoint, and it points to the local database because primary during the daytime in the US is located in the US. Now, of course, if somebody connects from Europe, or you travel and you connect from Europe to your data, then it will be inconvenient at that time. But good news is that this is the nighttime in Europe, so chances are very few connections will actually be active at that time from Europe. So we take that trade-off. Now, as time goes by, let's say around 11 p.m. in the US on the East Coast, you, what we call, do the planned failover. Planned failover is an operation that allows switching the role with full data synchronization, no data loss. It'll take a little bit more time, but it is appropriate because at that time, basically, the activity is very low. And when it happens, the primary relocates to Europe. And now, basically, it's morning. The European customers and users start connecting, and the performance is best in Europe at this point. Now, you still can connect from the US. And by the way, if you're just doing reads in the US, you're still performant because you're hitting your own replica, read-only mode in the US. Only the writes will be slightly less performant because of the latency between Europe and the US. And the same happens at the end of the day in Europe. You essentially finish the business, you switch it to Asia, and the Asian customers start sort of getting the best performance from that application. So the benefits is, as I said, it's optimized for access for the local user. And at the same time, read-only access is always the best performance. Now, the trade-off is if you actually have a disaster, let's say in the US, your failover endpoint will be in Europe. So after the disaster, that experience for the US customer will suffer because of the latency between the US and Europe. Now, this again just shows the power of the technology. It is not a disaster recovery scenario per se. It's a distributed application and relocation scenario using the failover method to relocate the primary. And the final one I'd like to cover is the case where you essentially implement kind of an active-active pattern where you have a SaaS application with multi-tenant pattern, and you have a clear notion that tenants are located in the region where they belong. So you have essentially partitioning of tenants per region or per geography. In that case, what you do is you produce the tenant databases according to the location of the end user. And those databases are naturally distributed across different geographies. So the idea here is we guarantee that write access is supported in the same geography for majority of the users. How is this done? Imagine you have two regions where your business actually is available. You have an application, let's say, in US and Europe. So you have European customers and the US customers. So all the US customers are, when they, let's say, create an account with a service, their tenant database is provisioned and deployed in the US and geo-replicated in Europe. And vice versa. The European customers, their databases are provisioned in Europe and geo-replicated in the US. Geo-replication for protection. The deployment in the primary region is for optimizing the access of the end user. So each region has sort of a combination of European and US customers with the appropriately placed primaries. So the only scenario where it is not as performant is if you travel. So in the travel case, when you're in Europe but you are a US citizen, let's say a US customer, you would have to go to the US tenant database, and that will be less performant because you will have to go through the web app application, Web App 1 in the US, let's say. So that is the case. But most important, interesting aspect of this pattern is that so if a failure happens, let's say US location is down for extended period of time, all the databases are recovered, but only 50% actually even impacted. Because all the European databases, the tenant that basically been placed in Europe, they just continue on. The European customers will not even notice anything. The failover will impact only the portion of your tenants that have to fail over, that have been placed originally into the US. So that's kind of the risk, spreading the risk kind of scenario where you partition the data, and because of this partitioning, you get impacted only, let's say, by 50%. Only 50% of your customers will ever be impacted by any type of disaster in any region. That is an important characteristic because it really reduces the exposure of your business to any kind of event. Now, of course, the benefit, like I said, is that the risk of any sort of impact, data loss or downtime, is reduced by, let's say, 50%. For impacted tenants, RTO is low because failover is a quick process. It takes minutes and you're back in business. And the end user in the same region always connect to the tenant database in the same region, which is again performance characteristic. As far as trade-offs, in this case, you have to use multiple failover groups. You cannot, because you know that you fail over only portion of your databases. And the failover group defines the scope of the failover. Performance is impacted when you travel, because you're kind of leaving your home region, you're in Europe, your performance will suffer a bit. So you basically will see that as a consequence of your relocation as an end user. And the other thing is your application has to have some sort of a catalog that has all the information about the location of specific account, specific customer. For example, when I connect, the application knows, okay, you have an account that is actually deployed in the US, and it will connect to the tenant database in the US. Again, depending where you are, you either get best performance or perhaps not as great performance in terms of the response time. That is the pattern that you can also consider. And by the way, these patterns you can mix and match. You can find, for example, that you want to do partitioning and follow the sun. Because in that case, following the sun will perhaps only apply to the catalog database that has all the information about the tenants, because the tenants are distributed. So you can think of this as an opportunity to build even more sort of sophisticated deployment pattern for your application so that you minimize the trade-offs that I've just explained. All right, so that is all we wanted to cover in this session. And I just want to go back to what we set out to do in the beginning, and hopefully you see that these powerful application scenarios are possible today. It's about the technology that we already have in Azure. You can start using them immediately. Now, hopefully you have some understanding of how these application patterns can be implemented using the failover groups and geo-replication capability in Azure SQL Database. So, as I mentioned, you can mix and match. You can look at this as a continuum. You can pick a simple one first. You can say, oh, let me just protect my application. And then if, for example, you move to a different region because of the business demand, you can start thinking about how can I relocate? How can I distribute my footprint to a different region and at the same time protect it? And maybe later I can start thinking about, oh, maybe I should distribute the risk. Maybe I should minimize it by partitioning my tenant databases into different regions. So you can sort of incrementally add value to your application by using this pattern. And finally, we want you to really explore the Wingtip application and learn and use it as a template, because it shows you how to integrate failover groups into multi-tenant SaaS application. Thank you very much for listening and downloading. That's all we have.
Thank you.